Hi, so this is the second part of the heat diffusion lab for EAS 217. Okay, so the problem that we're trying to figure out is the cooling of a lava lake. So consider the cooling of a stationary lava with an upper surface kept at an ambient air temperature, which would be up here, okay? Because of the lateral extent of the lava flow, heat can be considered to flow only in the vertical Z direction, this direction. Um, the loss of heat from the sides is not going to be considered, okay? So just on the Z direction. The lava flow is divided into different cells, as it's shown here. And the initial condition at where I drew this dot at T equals 0 of the lava is a uniform temperature of 1,200 degrees Celsius. So from here all the way down is going to be 1,200 degrees Celsius because we have to consider that the initial condition of the lava is uniform, okay, at all depths, except at the surface. At the surface is going to be 25 degrees Celsius. Okay, so I hope this is very clear, and I'm going to actually transpose this into the Excel file. So when you're like actually trying to build a table, it actually makes sense. And I put this little sunshine here for reference that this is the actual surface, and this is these are like the different depths. Okay. So as the lava keeps cooling, the surface of the lava is gonna remain at 25 degrees Celsius. Okay, so on the top is gonna be 25 degrees Celsius, and the rest is gonna cool down. Okay, because you have liquid, molten rock. Okay. So now, for now, and I'm just gonna tell you all the assumptions, and then you're gonna use this to build the table in Excel. Okay, so we will assume that during that 5-hour period, the lava at different depths, the lava at depths of 0.64 meters and below have a temperature of 1,200 degrees. So, I mean, okay, so like, let's say this is the bottom of the intrusion or the lava lake. So at this depth, if you keep going further down, we're just going to assume that is the same, like the same temperature. So we're only gonna have, I guess, like a row with that constant temperature, and then that's where we can end the model because it's a finite grid, right? Okay. So then we will also ignore the heat of crystallization. That is the heat that must be removed from a liquid as it freezes at a constant temperature, which is what's actually happening right now in this example. And I put this picture because we usually think of freezing as, when you freeze the water, but in this case, we're actually talking about magma, lava in this case, crystallizing. Okay, so now how are we gonna build a numerical solver? And I put like I tried to like simplify it here, like in steps of the assumptions and the different values. So the most important part of this is the first part, which says that it only works if little k times del t over del t squared equals 1. If you don't have this condition met, you cannot use this model. So if you want to use this model for another problem that you find, just make sure that this condition is satisfied. Okay, and we said little k is 10 to the negative 6. That's a typical value of meters squared per second. And delta t is going to be 30 minutes. So we want to have every 30-minute intervals. And delta z, which is the depth, we want to have intervals of 0.0424 meters. So, okay, now you can use these values to construct the grid in Excel. The column 1 is going to be depth, and column 2 is going to be temperature. Yeah, And at the top cell, which is z equals 0, the temperature is 25 degrees Celsius, because as we said, that is the temperature at the surface. And then also the temperature at z equals 0, like at the surface, remains constant at all times. So we're just not gonna take into account the heat going from bottom to top. And assume that we are far enough from the surface at the bottom row that temperature remains constant at 1200, which is what I already had explained in the previous slide. Okay, now pause the video and build the table in Excel. And we'll be right back, I guess. Okay, I hope you had some time thinking about it and trying to actually build the table. And now I'm gonna show you what it's supposed to look like. Hopefully this works. Okay, so this is the table. This is what it's supposed to look like. I even color coded it. So the red is where the lava is, and this blue is the surface. The purple is the time, and this is the depth in meters, okay? And I also put the grid here in case you had you wanted to make sure that you were transposing it properly. Okay, so I'm just gonna demonstrate how to use the iteration process so you can use it for this part of the table that you're gonna fill in. And I'm just gonna show you with a simple multiplication problem. Okay, so in this multiplication problem, we have 2 times 5 is 10. And we're doing it by referencing the Excel cells, okay? But now I'm gonna change something. I'm gonna go to calculation options and I'm gonna say manual, okay? And then also, I'm working on a Windows computer. So in Windows, you go on File, Options, Formulas, and then you wanna here enable iterative calculation, okay? And we're gonna say maximum iterations 1. So every time that you want Excel to calculate, you are gonna have to hit calculate, or calculate now. Or I think it's F9 in some computers. Okay, so once you have all that set up, see what happens. I'm gonna change one of these cells. So let's say 2 times 0. Oh, what? 2 times 0 is not 10. What happened? So now, if you want Excel to actually do it, you go to and click calculate now. And then it does it. Okay. Now, after you're done doing, you're gonna have to click this many times because we only did one iteration at a time. And here you have, I don't know how many, like a bunch of cells. So if you do it fast enough, it's cool because it looks like a wave. Anyways, so I demonstrate the iteration process. Oh, and once you're done with this table, make sure that you go here to calculation options and you put it back on automatic. Otherwise, your Excel is not going to actually do the calculations you want it to do. Okay, so try doing this now. And after you're done with this and you're starting to do the plot for question 1, watch the rest of the video. So now I'm going to show you, I'm going to give you some tips on how to do the plot because this was like the first time I was using Windows and it was kind of weird. So I took note of that. Okay, so I'll see you in a bit. Okay, so hopefully your table is done and you're trying to plot it. So these are like the 4 steps that I followed. First, I selected the data, then go to insert chart and select line, not scatter, because that's one of the mistake I did the first time. And then also make sure that the x-axis is the depth. Oh, that's wrong. This should be the y-axis. Okay, just a second, let me fix it. Actually, never mind, that is actually correct. The x-axis is depth and the y-axis is temperature. Sorry, I was thinking about the table. But this is for the plot, not for the table. Okay, and then obviously it's gonna give you the plot for all the half an hour increments. So if you just click on the line and press delete, it's gonna erase that from the plot. And that is the end of lab 6. Amazing. So remember to upload an Excel file with 3 tables and 1 plot. Answer the take-home questions on Blackboard, and this is due next Thursday. I'm gonna try to make these videos so whenever we meet in the lab, you can just like keep working on the file. I mean, whatever we're doing in the labs, and yeah, see you next week, I guess.